Okay, so today is the review. 12, 17, 18. All right, reference angle. So let's think about this. The whole idea of a reference angle is this. We need a right triangle.
I think it's 30 degrees.
Ben, you're right. Let me show it, okay? So to make a right triangle, 7 pi 6 on our unit circle is right here, or 210. It's easier to do the whole thing in terms of degrees. You guys agree? So if I look at this as really like a 210 degree angle, and you can get that from right here on the unit circle, right? Then if I draw my picture, let me draw my picture, and you guys can see this. Okay. The angle itself goes all the way around to here, okay? And so what we get is a 210 degree angle. Now, we need a right triangle because all of our sine, cosine, and tangent deals with right triangles. So that's why we do a reference angle. So what we do is we create a right triangle along the x-axis, okay? And the angle we need is right there. Let's just call that theta, okay? Well, out of 210, if this is 180 and this is 210, that angle's just 30 degrees. If this is 180 from there to there, that's 210, then a reference angle is 30 degrees, or in terms of radians, or pi 6. Same angle, pi 6 or 30 degrees, okay? And I'll take either answer, okay? So we need to make the right triangle because all of our right triangle trig is dealt with acute angles, not 210 degree angles. You can't even make a triangle out of that. Can't even make a triangle out of that, can you? No. Okay, so now number 2, unit circle, exact value. So tangent of 4 pi thirds. So if we look at our unit circle, we put the tangent values on our circle on the outside in orange. So if we're looking for 4 pi thirds is there. Tangent value is there. It's already on our circle. It's just the square root of 3. That's the answer.
That's it?
That's it.
We love that.
I know, isn't that nice? So we have to know how to use the circle, right? We know our tangent is the orange, right? So we go to 4 pi thirds. There's our answer. Okay.
And then the cosine of 450 doesn't find, right?
Yeah. So now cosine of 450 is like going around the circle and then a little bit more. Okay? So if I take 450, if I go 360 degrees, and then a little bit more, in fact, if I go 90 more, I would be at 450 degrees, okay? So if I went 360 and 90 more, it makes 450 degrees. So cosine is the x value, okay? So we're at 90 degrees. Cosine is the x value, so my x value at that 90 degrees is just 0. You want me to show it again? Okay. Now, cosecant's a little harder. Cosecant is 1 over the y value, okay? It's a negative 3 pi 4, so we've got to rotate differently, okay? So 3 pi fourths is here. 3 pi fourths is there. A negative 3 pi fourths puts us right there, okay? We want 1 over the y value. That's my y value. So we're going to go 1 over negative square root of 2 over 2. I would take that answer. I really don't want that answer. I wouldn't mark it wrong. But a better answer would be, or we could write as 2 over negative square root of 2, because when you have 1, flips a fraction, 1 over a fraction. And a better answer than that, if you really want to make me happy, it would be just simply the square root of 2, okay? Because you can rationalize it, okay? But I would take any of these 3, okay? Thumbs up. Okay. All right. Colby, here we go. So, there are 2 ways to draw graphs. One, if it's a sine curve, and if you're unsure how to do this, watch. We're going to take a roller coaster ride. A sine curve starts on a roller coaster down at the platform, and the coaster goes up. And then it goes like that. That's a sine. A cosine curve is more like the water slides. You walk up, and this water slide starts up here. See where it starts? So cosine starts up like a water slide. Sine curve starts down at the bottom and goes up. Okay, that's a cosine. So if I look at this, I like cosine. I think cosine is a great idea because it starts up, right?
Me too.
Yeah, you could call it a sine, but you'd have to start there. I think Lauren's right. Let's call it a cosine. There are really 4 correct answers, but let's pick the easiest, okay? Totally agree with cosine, okay? So let's go y equals cosine. Okay, now the amplitude seems to go up 1/2, doesn't it? Down 1/2. So my amplitude is 1/2. B, which is the frequency, is 2 pi divided by the curve width. Well, we took our one roller coaster ride and we did it in pi. The width is pi. You guys see that? So the width of my curve is pi, and then it does it again, it does it again, it does it again. But one full ride or one full period is pi. So B turns out to be 2 pi over pi, which is just 2. So I'll put my 2 right in front of the cosine. Now I like that Lauren picked cosine because it starts on the x-axis, or I'm sorry, on the y-axis. So there's no horizontal shift, none. So just plain old x. There's no vertical shift either, so we say plus 0. So we are done. That is the answer to number 5. Colby, that's going to help you finish up that worksheet, isn't it? Okay. All right, number 6, probably one of the easier problems on here. It says trig ratios. Well, another word for ratio means fraction. So we're going to use these. Now, r is not 1 because we're not in the inner circle.
Are those going to be up during the test?
Yeah, of course they will be. Yeah. So what we have to do is this. I know every point has an x and a y value. So for this circle, I know my x is going to be -3 and my y is -4. What I don't know is my r, but let's use Pythagoras Theorem to get it, okay? A squared plus b squared equals c squared, or we'll use our x squared plus our y squared equals r squared. That is Pythagoras Theorem. Okay?
-5.
It is going to be 5. It can't be -5 because a radius is always positive. Sasha asked the same question. Okay? So Ben's way ahead of me if I do -3 squared, right? Plus a -4 squared equals an r squared. 9 plus 16 equals r squared. 25 equals r squared. Square root of 25 is 5. R is 5, okay?
Wait, when did we learn this?
Pythagoras Theorem? A squared plus b squared equals c squared?
You learned it on
Yeah, that's all right. I just did it in x's and y's instead of a's and b's, okay? Same thing. Now, all we got to do is take these values, x, y, and r, put them in. That's all we got to do. Got to put them in. So, first of all, sine of theta of this angle is, it's the y over the r, so it's going to be my -4 over 5. Cosine of theta is my x over my r, which is -3 over 5. Tangent of theta is my y over my x, which is my -4 over -3, or 4 over 3, right? You know, same thing. Let's see, I need to do cosecant of theta, which is the opposite sign. Opposite sign, so instead of -4 over 5, it's 5 over -4. Okay. Secant of theta, which is the opposite cosine, which is 5 over -3. And of course, cotangent, I'll squeeze cotangent right here, is the opposite tangent, so it's 3 over 4. Okay, there they are. There's all 6. It's pretty easy.
Wait, it's 3 over 4, not -3 over -4?
That would be the same answer, yes. Yeah, I just got rid of the negatives, okay?
Wait, so Mr. Use the triangle, are you doing that
I'll show you.
one?
Well, can you scoot over? Or-
Yeah, that one right there. Does that make sense? Right? And because, Cody, it's in the coordinate plane, you don't really have lengths of x or lengths of y, you have coordinates. You with me? That's why it can be negative, because it's on a coordinate plane. Negative, negative. Where technically, if it's a triangle, you couldn't have negative lengths, right?
Yeah.
Okay. All right, number 7. Now, how the heck do you do this? Well, we are going to graph, in number 7, we are going to graph first first we're going to graph y equals negative 2 cosine of 3 theta. Okay, now, y. I'm going to show you why in just a second. Okay. So, secant graph. And hopefully you guys have these notes. If you don't, find somebody who has a copy. Get a copy, okay? But the cosecant, or the secant graph, literally comes from the cosine. You see the cosine in there? So once you get the cosine graph, your asymptotes are where cosine 0. Here, here, here. And then you put your up and down loops. So if we can graph our cosine, then the rest is easy. Okay? So let's do that. Let's get, first of all, graph paper. I'm going to go ahead and do this. Okay. XY axis. Okay. I'm going to go from 2 to negative 2. Okay. Because of the amplitude. Now, I got to be careful. I normally go pi halves, but I'm not. I'm going to go pi thirds because I need to take and divide my graph into thirds. So right here, that's why. I need 3 of them in it, right? So what I have to do is take my 2 pi and divide it into thirds, okay? So that's the period of each graph. The period of each graph is 2 pi thirds. That's my period. The period is the normal 2 pi. We're going to divide it into 3 parts because we need 3 curves. So instead of pi thirds, or pi halves, I'm going to go pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds. Say that again.
You still move 4 spaces on the graph.
Yes, yes, I always do. It just helps me. Because you know when we do the 5 points, Cody, remember how I showed you guys how to graph with the 5 points?
Yeah.
The 4 squares help me with 5 points, okay? 2 pi thirds pi, 4 pi thirds, 5 pi thirds, and 6 pi thirds, okay? All right. Let me sketch it in. It's going to be upside down cosine. We're going to have an upside down cosine. So it's going to look like this, my 5 points. Boom, 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 boom. There's my 5 points for my cosine. But it's an upside down cosine, okay? So I got my 5 points. So one curve is going to look like this. Okay. I'm going to do it again because I need 3 curves. So, okay. Boom, 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 boom. Okay. I'm going to do it again. I'll do my 5 points again. Colby, this is probably helping a whole lot, isn't it? Boom, boom, boom. Okay, now I have 1, 2, 3 cosines. I have 3 cosines. That's what I needed was 3 cosines, right? Now, the easy part's coming. Once you have this, then the secant's a piece of cake. It has asymptotes and loops. Am I going too fast? May I slow down for a second?
Yeah.
Okay. So I'll wait for you, and we're going to put in the asymptotes and loops. The asymptotes are super easy. Here, 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 here. The asymptotes are where it crosses the x-axis, because that's where cosine is 0. Can't divide by 0. So it gets easy at this point. Once you get the cosine in place, or the sine, whichever graph you're looking for, then the loops are easy. Okay, so then the actual graph has to come off of that. So my graph is, here's my answer. Here's a secant graph right there. There. So all I have to do is get the cofunction first, and then the rest is easy. How's that? No, just give me a few of them. Hi, Bella. So I got the review right here, okay?
You have sheets with those.
It's our review. Here. Oh, it's right here. Can I hand that to Bella? Okay. All right.
You have sheets with the secant graphs on.
It's such a
I
interesting rock.
do, but somebody borrowed my graphs and I don't know where they are. How's that
Yeah,
for an
that's
answer?
fine.
Okay.
Thank you.
I know somebody, one of these really nice girls probably has. Ben's got some good graphs too. Ben does. Okay, right? You guys ready for number 8? Or did I go too fast on that? Okay, let's look at number 8. Now 8 and 9 are the easiest. Here we go. Here comes the easy stuff. You ready for the easy stuff? 8 just has a simple formula. We're going to convert. We have a formula where we're going to say degree is equal to my 180 over pi times my radian, okay? That's my formula. So I'm going to say my degree is equal to 180 over pi times 5 pi eighths, okay? So I'm just going to use my formula, put 5 pi eighths in for the radians. Okay, I'm going to simplify. Pi cancels the pi. And I'm going to use my calculator. I'm going to go 180 times 5 divided by 8. And I think it's 112.5. I did last period. You can check me. I think it's 112 degrees. Okay. I got it, yeah. Yeah. Okay, number 9 is the other formula. So we're going to go, our radian is equal to our pi over 180 times our degree. Okay, there's our other formula, okay? All right, so we're going to go, all right, our radian is equal to pi over 180 times negative 200, okay? So what I want to do is make this a fraction and reduce. So I can rewrite this as really negative 200 over 180 pi, and then I'm going to reduce my fraction, okay? So I'm going to make it into a fraction, negative 200 over 180. I'm going to reduce the fraction and keep it in terms of pi. Right, right. So I'm going to reduce this, I think it's negative 10/9. Okay, that's the answer. How's that? That's the radian equivalent for negative 200 degrees.
Did we do this on the last test too?
Yeah, a little bit, yeah. Yeah, so last test was actually a quiz, like a mid-unit quiz. This is a chapter test. Okay, 10, pretty easy, okay? Oh, by the way, I did make a mistake. Change that to feet. Change that to feet, because I've got 2 different units going on. My bad, that's got to be feet. Sorry, I know, I should have left it metrics. I know. But then I would have had a 6-meter man.
Having such a hard time with those.
I know. Can't have a 6-meter man. I could have had a 2-meter man, right? 2-meter man? Yeah. Yeah, better than a 6-meter man, right? Okay, here's my man. He's just hanging out, looking at a building. He's just chilling. Okay. He's going to cite the height of a building. The triangle that's created, the invisible triangle that's created, is really suspended 6 feet above, right?
Mm-hmm. So we're going to have to add 6 to the end.
Totally right, Ben. 100 feet away, 54 degrees. We want the building opposite. We know the adjacent 100, right? So we're going to use tangent. Opposite adjacent, right? You guys agree? Opposite adjacent, we use tangent of my angle, which is 54, equals my opposite over my adjacent. Multiply by 100. I'm going to go 100. Tangent of 54 equals x. Is that 137.6?
Oh, no, I think I'm wrong.
I don't know. What's...
What are you asking me? I might be wrong. I'm not wrong.
100. You got to multiply. Tangent 54. 67.4. 67. I got about 67.4
Plus 6?
plus 6. Is that right? That can't be right.
No, it's 137.
I thought so. You're on the wrong mode. Oh, you got to make sure you are in degree mode.
Oh, that's what
Okay.
I meant.
All right. Lauren, what'd you get? I mean, Colby, what'd you get? 137.6 equals x, and then add 6 with 6 feet. What's that, 143
Yeah.
feet? I don't know. You did, though. It's all good.
Make it longer.
You did. Okay. Sound good?
That sounds good.
All right, now let's practice. See, the tide problem is the big problem, right? So let's practice it one more time, all right? Okay, let's practice.
Super wobbly.
Oh, I'm sorry. We'll come in on vacation and I'll tighten some things up, okay? Okay, you guys ready for 11? Am I going too fast or am I okay? All right, here we go. Hey, I got this in meters. How do you like that? This one's in meters.
Oh, it sounds good.
Okay. Here we go. All right, I'm going to go over a 24-hour period, right? All right, here we go. Let's see, we're going to go 2 and -1. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is 1 o'clock, 14, 15, 3 o'clock, 16, 17, 18, which is 6 o'clock, 19, 20, 21, 22, 23, and I'll go to 24, so I do a full 24 hours. There's midnight. I got noon right there, and I've got midnight again. All right, I'll let you catch up. Okay. Okay, 0 to 24, right? AM, PM, right? Okay. All right, let's see what I have. 1 o'clock, height of 2 meters. Okay. 9:30, -1 meter. All right. So what I always do first is try and find out the time between high tide to low tide. So I need to know this time right here. What's my time from high tide to low tide? Let's see.
8 hours and 30 minutes.
There you go. 8 hours and 30 minutes is totally right. I'm going to call it 8.5. Yes. Yes, yes, yes. Okay. Everybody agree? So then the next high tide, let's do it again. Another 8.5, right? There's half. 1, 2, 3, 4, 5, 6, 7, 8 is right here is my next high tide. Okay, so then I'm going to put a dot right there. And I can answer some of my question. I already know next high tide is at 1800, or in military time, what's that? 6 o'clock p.m., right? You guys okay? So I can put down, when is next high tide? 6 o'clock p.m., right? Got that. Right? Got that. We just got that. Boom. Okay, now comes the hard part, the equation, right?
Wait,
I will wait for you.
can I see that?
Yeah. Okay. So, to get the equation, we're going to write our y equals a cosine b t minus h plus k. That's the equation we're going to use, okay? We've got to find a, we've got to find b, h, and k, right? And I'll wait for Lauren to give me back my graph, and then we'll work on it, okay? Am I good? Okay. Tell me if I'm going too fast. Okay?
Plus K?
It is plus k, because that's your vertical shift, right? Okay, Ben, how are we doing? So let me go ahead and graph my curve, right? My curve looks something like this. Okay, there's my curve. So, amplitude. Let's figure out amplitude is first. My amplitude is max minus my min divided by 2, right? Amplitude is max minus min divided by 2, 3 over 2, or 1.5, okay? All right, B is 2 pi divided by the curve width. My curve width is 17 hours, right? Hopefully I'm not going too fast. Yeah, that's my, because it's always 2 pi, and then divided by the curve width, and it's 17 hours from high tide to high tide. It takes 17 hours to go from high tide to high tide. It does. Okay, now let's start making it. So I've got to have a y equals a 1.5 cosine. So let's start making this graph. Cosine 2 pi over 17, right? T, because of time, or x. Now, the graph did not start on the y-axis. Didn't start at midnight, did it? So it got pushed forward once. We'll back it up by go t minus 1. And then the whole graph is up a half, but if you can't see the vertical shift, k is always going to be the minimum, which is -1, plus my amplitude, which is 1.5. So my k is equal to 0.5. And there I have it. There's my answer.
It's actually equation.
Right there.